Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today. Target sum, Leetcode 494. In this problem, we are given an integer array nums and an integer target, and we want to build an expression out of nums by adding one of the symbols plus and minus before each integer in nums, and then concatenate all the integers. For example, if nums is 2, 1, we can add a plus before 2 and a minus before 1 and concatenate them to build the expression plus 2 minus 1. And we should return the number of different expressions that we can build which evaluates to given target. Then in example 1, for the given nums array and target equal to 3, the output is 5 because there are 5 ways to assign the symbol to make the sum of numbers equal to target. One way can be that we put minus in front of first one and then all the pluses. So first one and second one will cancel out and sum of remaining ones will be equal to target 3. Another approach can be that we put plus minus plus plus plus, and again these two ones can cancel out and sum of remaining ones will be equal to target 3. Then the next way can be that we put plus plus minus plus plus, and again these two ones can cancel out and again sum of remaining ones will be equal to target 3. Then the next way can be that we put plus 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 minus plus, and again these two ones can cancel out and sum of remaining ones is again 3. And finally, the last way can be that we do plus 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 minus, and again these two ones can cancel out and the remaining sum will be equal to 3 again. So in total there are 5 ways we can write the expression summing up to target number 3. Now in terms of solution, the naive approach to solve this problem is to use a recursive method that explores all the possible combinations of plus and minus for each element in the nums array. Let's also initialize the variable current sum to track the sum of numbers after putting plus or minus before them. And initially its value is 0. And then for each number we will have two choices, either to add the number to the current sum or subtract the number from the current sum. For example 1, either we will be doing plus 1 for the first number or minus 1. Then for the next number we will be doing plus 1 again or minus 1. Similarly, for this side of the tree as well, we will have plus 1 or minus 1. And this process will continue until we reach the end of the array. And once we reach the end of the array, we can check if current sum is equal to target. And if it is, then we count that expression as a valid one. So continuing with our recursion tree, for the third number, we will again choose plus 1 or minus 1 and so on. I won't draw the whole tree, but this is how the tree will look like. And to track the current sum here is 1. Then the current sum becomes 2 here, 3 here. Similarly, here the current sum becomes 0. And then here the current sum becomes 1. And similarly for this side, the current sum becomes minus 1, minus 2, and again 0, and so on, right? And then for the third index, we will again do plus 1 or minus 1, and so on. And then for the last element, we will again do plus 1 or minus 1. And now we have come to the end of the recursion. So we check if current sum is equal to target sum. So here, for example, current sum becomes 4. Here it becomes 5. So current sum here is not equal to target sum. But here the current sum becomes 3 because we subtract 1 from 4. So that's why we will get 3. So this actually matches the target sum. So we will count this expression as a valid one. And similarly, we will count all the valid expression in the remaining recursion tree. Now in terms of time complexity, it will be O of 2 to the power of n, where n is number of elements in the nums array. Because at each level or for each number, we check whether to add a plus sign there or a minus sign there. So because of this, we will build this recursion tree of size 2 to the power of n, resulting in time complexity of 2 to the power of n. And in terms of space complexity, it will be O of n because of the depth of the recursion tree. Now let's jump into the code part. Let's make a call to helper function calculate, which counts number of valid expression. We will pass in the nums array and the target, starting with index 0 and current sum set to 0. Now let's define this helper function. First we will check the base condition for recursion, and that will be if we have reached the end of the array, that is index is equal to nums.length. If that is the case, then we check if current sum is equal to target. In that case, we will return 1 indicating the valid combination, otherwise we will return 0. And once we are done with the base condition, now we have two options. Either to put the plus 1 before the number That is, we add the number to the current sum, or we can do the subtraction where we put the -1 before the number. And in any case, we will go to the next index to perform the same operation. And once we are done with both the recursive calls, the sum of add and subtract will be our answer. That is, total number of ways to reach the target sum from this point. Now let's submit this code. Awesome. I am surprised that this code got accepted even though the time complexity is super high. And now the question is, can we do better? And the answer is yes. If we look at index 1 carefully, current sum is 0 at this point and this point. From here on, we can place plus or minus before the remaining numbers in both the paths, and the subsequent trees will be exactly same. So this means we have overlapping subproblems, and we can introduce memoization where each subproblem can be defined by unique index and current sum. And to perform memoization, one way is to create a 2D array of size n into 2 into sum, where sum is total sum of all the elements in the array. This is because the potential current sum can change from sum of all the elements if we put pluses before all the numbers, or minus sum if we put minus sign before all the numbers. However, another trick which I sometimes use to avoid fixed size matrices is using hash map, where key is string and value is the computed result in the recursion. So in this problem, we can create key like index, current sum. For example, for the index 1 and current sum equal to 0, we can create key like 1, 0, or we can also join index and current sum by dash and greater than sign. So whatever key we choose to store the results, and then we want to check if the key already exists in the map, again we can construct the key like this and check if we have already computed the result. So now with memoization, the time complexity reduces to O of n into 2 into sum, or n into sum basically, because we will be filling or computing the results for these many keys in the map. And the space complexity will also be O of n into 2 into sum, as we will be storing these many subproblems in our cache. Now let's jump into the code part. First, let's create the memoization map to store the result of all the subproblems, where key will be string, which will be computed based on the current state, that is index and current sum, and value will be the result. Now let's create the unique key for the current state. We can join index and current sum by comma for that. And now we check if we have already computed the result for this state by checking for corresponding key in the memo map. And if the answer is yes, we will return the result stored in the memoization map. Otherwise, we will continue with the recursion. And now we will store the result of addition and subtraction in the map and return the result of the current state like we were doing earlier. Now let's submit the code again. Cool. This time it is faster thanks to memoization. We can make it even faster using a bottom-up dynamic programming approach, as it will reduce the recursion overhead. However, the time complexity stays the same. I will try to make a follow-up video to explain that approach. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.